What's going on? Alright, my name is Shaquille Ankrum. This is Lab 4 on Faraday's Law. Let's get into it. So, the purpose of this lab is to collect and observe observational data of a bar magnet falling through a magnetic tube. And by doing this, we'll be able to model the interaction between the magnet and the aluminum surroundings to demonstrate proof and action of Faraday's Law. And here are a preview of the results. We had the average time of 2.65 seconds and then our model time of 2.932 seconds. So, fundamental principles, we have Faraday's Law, Lorentz force, and Newton's second law of motion. In this experiment, our system is the bar magnet, the surroundings is the aluminum foil, as well as earth and everything else. And initial conditions, the magnet starts from rest and falls from rest. The length of the bar magnet that we have was 0.3 meters. It had a mass of 0.025 kilograms. And as mentioned before, the average trial length was 2.65 seconds. So this was my the code for generating the tube, as well as that's supposed to say generating the magnet, but generating the magnet in the tube. And then it's the code for calculating the magnetic flux, and then the magnetic field, and then derivative of the magnetic flux, in order to do the computations or whatever. And then this is the result I got. As you can see, the from the model, the magnet, did its thing. I'm so tired. Conclusion: experiment and the code were close. They were very close. So that means we did a good job with the experiment. Potential sources of error. Human error is always a potential. It's always there, ever lurking, present. And we have, maybe rounding errors because I'm getting the time code from the magnet dropping. There's potential round error. Also, I didn't put this too, but just like I guess it goes with human error, but just dropping it because it took me a while to get it. Because sometimes it like hit the sides or whatever. So I wanted to get it like to go like straight down or whatever. But that is a problem too, because of course in the model it's not gonna, it's not gonna model the magnet hitting the fucking cardboard or whatever. It's just gonna go straight down. So what if? So what if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? Well, the induced current in the tube would increase, and then current increasing means the magnetic force would also increase, meaning that the magnet would fall even slower because the whatchamacallit, the magnetic flux would be increased. On the opposite side of that, if holes and slots would cut into the tube, how would this affect the ring currents in your model? The induced current would decrease because the rings are made shorter, and of course this would mean the magnetic force would decrease, and this would mean that the magnet would fall faster because the magnetic flux is decreased. It's not as intense. Yeah, that's it.